Okay, for now we are able to get the messages to our MQTT broker, and now we are going to see how we are going to process that message in our virtual machine or Raspberry Pi. This was our whole system block diagram, and now we are going to see what is happening here. We will have here in the virtual machine or Raspberry Pi, we will have this MQTT broker, Mosquito broker, and then we will have this web client gateway software which will receive the message MQTT messages and send those forward to REST API interface to get the measurements to our database. So this next is that we are looking about how this part is working. The high level description of the gateway software is here. It's first we initiate these variables, and then this software is done so-called thread based. So there are some threads that are running, and there's one thread that is listening these MQTT messages and then working according those messages. Basically there's one thread that it is in endless loop, and it is checking out that if there are MQTT messages coming. And then there's callback function. When these messages are coming, the callback will be called, and then we know that we have received the MQTT message, and after that we are parsing that message, finding out this name value pairs, find out those pairs there, and then when we get our signal name and the signal value, then we create again a JSON message that we are sending through REST API to our database. And when the REST API JSON message is created, then we are sending that message to database by this CUL, by using the CUL libraries. If you log into virtual machine or Raspberry Pi, there are these directories for different classes, and now we are, as an example, we are finding out what is this alloc A class. So each of these directories belong to certain classes. And if we go to our own directory, we found that we will have here some different kind of source files and header files. And there are these main functionalities are in these three files. The main file, there is the functionality which will start these threads and do the initiate needed variables and so on, what is needed. And then there's this MQTT Arduino one. This is the part that will receive those incoming MQTT messages and handle those messages, do the parsing for the message, and dig out the right parameters from there, your signal name and the signal value. And then the last part is that send thumb source file, which will do the sending to database. So this will use the REST API to send our measurements to our database. And here is the file structure of the directory, and also there are these header files which are related for those source files. And in the header file MQTT-H, there are defined our topics, and are we working with the local host or subscribe to some other device. But in this case we are subscribing to our local host, and the port numbers and client IDs. So these are defined here. So if you need to change the topic, you should edit this MQTT H file. As discussed earlier, there are 5 different tags that our parsing software try to find out, and in this exercise, the only mandatory what is used are the signal name, S name, and S value. These are the tags that we are using in this exercise. The software is also digging out this path, unit, and data, but we are not transferring those forward. And here was that example of that incoming MQTT message from Arduino. And as discussed earlier, there's this prefix, and then there's the JSON message between the curly brackets. And in fact, this is the message that we are handling in this part of the software. As I said, this part of the software is doing also the sending the database to REST API, and this is the syntax for outgoing messages, the message that we are sending to our database. There we will have a device ID name, and the value for that is ICT 2020, and after that there's the followed about the data part, and in the data part there are these pairs, sensor name and sensor value, and it's possible that the data part contains about several of these sensors. In this example we have only one pair, but it's possible to add as many pairs as needed for the data section. So here is example that if you would like to say the 3 different measurements in one data section, there was this device ID and the value for that, and in the data section there are these name value pairs. In here 3 measurements, the name, value, name, value, name, value, and so on. And the libraries that we are using in here is this MQTT library. It's called Mosquito PPP, and then we are using this CU library, which is used for the send the HTTP REST API messages, and JSON parser is used for that, to parsing out about the incoming JSON message or the JSON format from the MQTT message. Okay. Now if we open this MQTT Arduino 1 source file, and let's look at which kind of methods, functions we will have there. So that class has been inherited from this Mosquito libraries, and there are this library, this onConnect, onMessage, and onSubscribe are those callbacks from the libraries, and then there's one function that ICT REST, which is done for this purpose, to handle that incoming message. We will look at that a little bit later, but these are the methods that we are using in our exercise. If we look a little bit the main source code, there is that the one thread that we are running, and inside the thread there is continuous loop which will keep this MQTT functionality ongoing. So it will run it, stay in this loop, and check out that if there are messages coming, this will keep the MQTT connection ongoing. And if we go to see how this MQTT message is handled, of course first we have to connect to MQTT server, and That's done in this construction part of our class methods. And here we define these ports and IDs and host IP numbers and the keeper lifetime. And in here in this line now we do now the connection to our server. And then there are these callbacks functions. When the connection is okay, then this onConnect callback function will be called, and then we inform about the user by printing information to terminal that connection is done. And when we have connected, then we could go to wait if we will get any messages. And this onMessage callback function will be called when we receive some messages with our right topic. This is also checking the topic, but where this callback function is not called, this is not called unless we have get the message to right topic that was defined in the connect part. And in here, main thing what is happening here is that we are checking the prefix, because we agree that we should have a prefix in our message IOTGS. And in here we are checking that if there is right prefix, then we are going to call this ICT REST function. If the prefix is right, then call the ICT REST function. And what is then happening in the ICT REST method function? There we are doing the parsing. We are parsing the JSON message, and we will check that if there is name sname, or is there name sValue in the JSON message. And if we find this kind of name there, then we know, because this was the name value pair, so then the value of this tag is the sensor name, and we save that to variable named sensor name 1. So then if we find this kind of tag, then the sensor name will be set for this variable sensor name 1. And also we check that are there a tag sValue. If found, the value of the sValue will be set for the variable sensor value 1. So then we got the sensor name and the sensor value. And the content of these variables will be used to create the outgoing JSON message. The outgoing sensor message data section, there was pair sensor name and sensor value. And then when that is created, then we will call the send function, which will send the data to REST API by using these UR libraries. And the parameters for this send function, there is that the address, internet address, IP address, and then there is the data part of that.